Now, the starting point with AI, if you're going to learn AI, is you got to know some terminology. I cannot stress this enough. You definitely don't want to be moving forward in this course without knowing this terminology and understanding this terminology before moving forward. So let's spend a little time understanding some terminology before we jump in and start playing around and getting hands-on and all that. So the first thing we have is what we call the layers of machine learning. A lot of people didn't realize this, but the term AI, machine learning, or artificial intelligence, machine learning, and deep learning are not just like three different terms. They're actually encapsulated in each other. At the top level, you have what's called AI, that's artificial intelligence, and that's basically, they call it the science of making machines work like and think like a human. Okay, so the goal is to try to make a machine that or electronic device that acts and thinks like a human, right? Then you've got machine learning, which is a step underneath that, getting a little deeper. This is making software applications that are going to be able to predict the outcomes based on certain criteria, certain classifications, certain labels. The goal is to make, with machine learning, the goal is to make it be able to predict something, predict facts, analytic data, all that based on the data that's fed into the machine learning algorithm. And at the bottom level, the deepest level, pun intended, we have deep learning. And deep learning is, the goal is to operate like a human brain. So this is using AI, building AI networks based on the way the human brain works, which is a network of neurons. So you have a similar type of setup with machines all connected together in this vast network to operate like a neural network does in the human brain. And so, of course, this is where AI starts to kind of get a little bit scary, and you start worrying about AI taking over the world and all of that. Well, that's deep learning. That's when you start getting into deep learning. Because AI becomes, as intelligent as human, and technically it could become way more intelligent than a human when it's all said and done, right? Moving on, so then you got key elements of AI, some more terms that you're going to want to know. Machine learning, the idea here again being to learn and predict like a human. You have computer vision, which is an AI element. This is visualizing objects like a human. You have conversational AI. This is a AI that's able to hold conversation with the human, kind of like we would use an AI bot. You have anomaly detection. This is AI being able to detect things that are out of place. So AI is able to get a bunch of type of analytic data and be able to determine that something shouldn't be there or something is not right. Then you have NLP. This is natural language processing. And this is the idea of being able to process language like a human. So this would involve things like being able to translate language, but also understand conversation like a human does. Next up, we have data sets. So this is another term you're going to hear. One of the things that we deal with machine learning is feeding data into a machine learning engine. And generally the way that happens is with a data set. A data set is a collection of data that's going to be used by your AI model, basically the engine with the model that's going to be able to receive an input and then generate an output. The idea of a data set is to act like an example to teach the machine learning algorithm how to make predictions. So you're going to keep feeding lots and lots of data in through a data set, and then based on you're going to tell the machine learning model how many guesses it got right of its predictions and how many it got wrong, and it'll get better and better and better. The more data you feed in there, the better it's going to get at figuring things out. So the types of data sets you'll have: text data, image data, audio data, video data, numeric data. So lots and lots of different types of data. The data is going to be usually labeled, annotated. I'll explain more about what that is in just a moment, in order for the algorithm to understand what the outcome needs to be. So again, you're going to feed data in, it's going to send data out, you're going to tell it how many things it got right, how many things it got wrong, and then it's going to fine-tune itself just like a human being would, right? So if you think about a child and you had a bunch of different objects, and some of these objects are squares and some of these objects are rectangles and triangles, and you're trying to help that child sort those objects into different categories. triangles, stars, squares, all that. And how many of the objects did the child get right for deciding what's a star, what's a triangle, how many they get wrong? And then basically you do it over and over and over, and what happens? You eventually teach that child how to get the right answer, how to recognize it. And this is sort of the idea of data sets, right, with machine learning. So what is labeling? You heard me use that term. Another term you heard me mention was annotation or annotating. And that's one of those like definitions, those words that most of the time people don't really know what it means, so I thought I would include the definition here. So annotating is any action that deliberately interacts with a text to enhance the reader's understanding of or recall of that text. And it doesn't necessarily have to be text. It could be anything. Any type of object, again, going back here, text data, image data, audio data, video data, numeric data. Either way, you are specifying. Annotating is the idea is giving information that's going to be associated with something that helps somebody figure it out. Okay, for example, if I said that there is a drawing on the screen, but you couldn't see it, and I had to describe it to you. Some labels that might be is that the symbol is square, and there's also a triangle on top, and inside that square is a rectangle and two small rectangles, and I could explain the colors. And turns out if I annotated enough, you could figure out that maybe there was a drawing of a house on my screen, right? That's an example of that. So that's the idea of annotation. So data labeling is defined as the task of annotating data. So now that you understand what annotation is, labeling is annotating that data. That means taking data and then giving it a label. Okay. If I had a bunch of pictures of flowers, one label might be flower, and then I might also label the colors. Some of the flowers are red, some of the flowers are blue, some of the flowers are green. And we could also label the type of flower if we knew that. That's a rose we're looking at, right? Anyway, you get the idea. Hopefully you can label. That's the idea of data labeling. So, and again, this can be done with images, data, text, videos, audio. Labels can also include bounding boxes and segmentation masks. So like if you're talking about an image, and you could use a box to label a face that would basically say, hey, this is a human face. You could have another box underneath that's a rectangle that goes around somebody's glasses that says, hey, this person's wearing glasses, so on and so forth. All right. So data labeling, this process in the beginning might be human powered to help the model work, to teach the machine learning models what it's actually seeing, so that eventually it can do its own predictions based on the labels that it's learned. All right, this is all stuff you're going to learn. Again, labels can be simple. They can be more complex. You can have lots of labels. Might have one label that just says, hey, this is a human you're looking at. But then we could have labels that say, hey, there's eyes, there's a nose, there's lips, there's ears, so on and so forth for labeling. So that's the idea of labeling. All right, the last thing we're going to look at here when it comes to machine learning is the three different model categories here for learning, and that is supervised, unsupervised, and reinforced. So supervised learning, SL, the idea here is this is a use of labeled data sets to train algorithms that need to classify data or predict outcomes accurately. So supervised data learning, you're feeding information into the model so that it can learn. This is usually used for making a prediction. So you're feeding lots of data in there to help it learn, and then eventually it can be used to make predictions based on the data that you're feeding in. It could be that you're feeding in a lot of metric data, and then you would help it try to make a prediction based on that. But it's kind of like imagine if you had a bunch of data based on earthquakes. Let's say you take the last 100 years worth of earthquakes for a region of the world like the west coast of the United States. you might be able to predict when the next earthquake would happen. I know that's not perfect science to that, but you could utilize machine learning to assist with that. You could use it for weather and other uses, obviously. So that's supervised learning, okay? Then you got unsupervised learning. So the use of unlabeled data sets, which requires a machine learning model to do its own labeling. So usually used for recognizing a structure or a pattern. So this is where you feed a bunch of information into the machine learning engine, and you allow it to try to figure things out on its own and perform its own labels, its own labels or its own classification. So this is good for recognizing patterns, colors, if you were talking about visual, but again, text, patterns, and all of that. Then you got reinforcement learning. This is probably the most interesting of the three. So the idea here, this is the definition for this is it's centered around a digital agent who is put in a specific environment to learn. Similar to the way humans learn new things, the agent faces a game-like situation and must make a decision, a series of decisions to try to achieve the correct outcome. So if you've ever seen, there's lots of YouTube videos of people out there playing around with this in video games. They're teaching characters how to maneuver around a game area, like a maze or something like that. I watched a video not too long ago that kind of fascinated me of somebody who took an older game called Tomb Raider. You might have heard of it. Back in the 1990s is when the first Tomb Raider came out. But this person taught AI how to play this game, Tomb Raider, which is pretty impressive. It's probably the most sophisticated game I've ever seen AI take on. But that would be an example of reinforcement learning. So the AI, you set clear goals for the AI, and the AI just tries different things. And the beauty of it is it has the ability to try thousands upon thousands of attempts within sometimes just a few seconds, whereas a human being couldn't do that. So it's able to, the downside of that is that sometimes the attempts are really bad attempts, but it's able to cycle through those so quickly that it figures things out relatively fast in a lot of cases. So this is for game AI, learning new tasks, robot navigation, things like that. That's what reinforcement learning. So any scenario where you've seen AI being used to train something to do something, maneuver or take action, that's usually going to be reinforcement learning. All right, well, that's going to conclude our introduction here and basic terminology that I wanted to go over before moving on. Now that we have gone over this terminology, we're ready to move on with the course. I'd now like to spend some time discussing the concepts of anomaly-based detection within Azure. So the first thing to talk about here is what the Azure Anomaly Detector is. Now, the Azure Anomaly Detector, this is a service that we have in Azure that's an AI service. It also has API connectivity with it, which basically means that there are APIs, application programming interfaces, that developers can send information to and have the Azure Anomaly Detector process that information. Not to mention, you can do this directly through the Azure portal. You can upload information directly, or if you're working with developers who are writing code, they can write code that will allow data to be sent directly into this Azure Anomaly Detector and have it process that information. Now, one of the key things about this anomaly detection that I want you to remember for sure here is these keywords: time, series, data. So what this is going to do is it's going to allow you to send metric type data with numeric values and all that can be sent to the Azure Anomaly Detector, and it's going to utilize machine learning to try to gather information from the data that it's got and then try to look for validation of any type of anomaly that it's discovered. Okay, this can happen in batch validation, which means you can upload lots of information at one time, or it can happen in real time where you're actually streaming data to it and it's processing it that way. So when it comes to anomaly detector, there's essentially two different methodologies that can be used for this. The first is called Univariate anomaly detector, and the second is called Multivariate anomaly detector. In a nutshell, Univariate is going to look at anomalies for just maybe one variable. For example, you might be looking at the cost of something, the revenue of something, the chances that something has failed, how many times it's failed. There's various things that you could use this for, but you're basically trying to hone in on a single anomaly type scenario in utilizing a univariate detection strategy. With multivariate, in a nutshell, the idea there is you got multiple variables that you're looking at one time to try to discover if there is some type of anomaly based on a bunch of different variables at one time, a series of variables. Okay, now don't worry, I'm going to explain these more thoroughly coming up. All right, we'll start with talking more about univariate anomaly detection. So with this, again, this is part of the anomaly detector APIs that we've got built in, so you can utilize the Azure graphical portal and all that to interact with this, or you can write code to interact directly with the API that way. All right. But this is going to allow you to submit time series data, and based on a series of algorithms that we have with this machine learning, it can determine what is considered normal based on the information that's been gathered, and then determine what is abnormal, which of course lets us know that there is some type of anomaly. You can see in the little graphic there, just like a little graphic example, where you've got anomalies going on there, where things are kind of an average numeric value, and then it's jumping up from 200K roughly to the 220 mark. All right, so that's the idea in this little example that I'm giving you. Now, another thing about, and this is just kind of continuing with univariate anomaly detection, when you use this anomaly detector, it doesn't require any kind of prior experience in machine learning. It does support the REST API, the Representational State Transfer Application Programming Interface, which essentially means that, again, pretty much any type of software that can support REST could submit data to this anomaly detection engine, which can then go through and try to process this for you. All right. So, and this can happen, this is an automated thing. It is not something you have to manually trigger. Unless you want to manually trigger it, can happen automatically. Now, there are three main features when it comes to univariate anomaly detection. You have streaming detection, which again allows data to be streamed. So data can be collected from something like a website or some kind of an app. And then from there, that data can be streamed to your univariate anomaly detection streaming detection feature. All right, and so this API can generate data in real time based on that. Then you've got batch detection. Batch detection is where you've collected maybe data over a period of time, and you want all of that data to be basically processed through the engine to see if there are anomalies. And then the last thing we have there is change point detection. So this is going to look at trends for types of existing data, and then generate models of trends to try to give you like a visual graph over a series of time to that you can go off of. Now, what's great about that, when it builds this model, you can then apply that model to other collected pieces of information and look for anomalies that way. So that's the idea. You're building a model based on this change point detection. You're going to reapply that model to other data later down the road. Now, the last thing we've got here is multivariate anomaly detection. And the idea here is this is going to let you gather multiple metrics from various objects. And you can see here it'll let you actually do up to 300 different signals. So you'd have 300 different types of objects sending data. And then from there, it can try to look at anomalies. But what's really neat about it is it can, if it's doing this all based on time, it can analyze all of the data and look for an anomaly based on a specific time. For example, imagine you had a a vehicle, a car or a truck or something that supported AI, and it was gathering, the computer inside the car was gathering information from all the different components of the vehicle. And from there, it might notice at a certain time, it isn't just one object that has an anomaly, but a bunch of objects. And based on data that's been collected over time, it can look for those anomalies later. Like if you look in that bottom little graph picture I've got there for you, you can see that the areas that are red, perhaps it's noticing a anomaly across all the chart, not just one object, but a bunch of objects at a time, and then that can provide information about a possible failure, something like that. Maybe a bunch of components that are reacting together at the same time could forecast the fact that you're going to have a failure, such as like with a vehicle or something. I'm just using a vehicle as an example, so you can kind of see where that comes from. All right. But that is the idea of a multivariate anomaly detection. Hopefully you have a better understanding now, at least the ideas behind what anomaly-based detection is going to help us with. I'd like to show you now an example of using univariate anomaly detection with Azure. Microsoft set up a little website here. I can go to algoevaluation.azurewebsites.net, and I can click on this univariate anomaly detector, and they've got some sample data that comes from a CSV file that we can check out. Now, in order to do this, though, we actually have to set up, so if we go to sample, we actually have to set up a anomaly detector in Azure. Like if we try to start, you're gonna see that it needs what's called an endpoint and a key in order to do this. So before we try to analyze this data to look for anomalies, we need to create this component in Azure. So we're going to go over to portal.azure.com, click the menu button, go to all services, and I'm just going to search for anomaly. And if we do that, you'll see anomaly detectors. We're going to click that, and we're going to click to create a anomaly detector. From there, once a resource group, I'll just call it AI Demo RG. And then from there, I'm going to do East US as my region. We'll call it Anomaly Demo. That'll just be the name of this component. Subdomain name already used. We'll say ELP for exam lab practice. Got to be a unique name. So pricing, we're just going to go with standard. You can view the full pricing details here, which I'm not going to dive deep into that just yet right now, but you can see there we are allowed to play around with the free one. 20,000 transactions a month, 5 hours of training free per month, 20,000 inference data points, and then you start getting into standard and all that. But if you got a free account, you can play around with free. I'm just going to go with the standard S0 here. For me, I have a paid Azure account. But I'm going to click from there. I can also configure networking. I'm not going to get into that right now. And identity, not going to get into that right now. I'm just going to click review and create. All right. And then once that's done validating, we will go ahead and click to create. Now keep in mind, this will take a couple of minutes to get created. So while that's being created, I'm going to pause the video, pause the recording while that's happening. Okay, now that that's done, I'm just going to click Go to Resource. That's going to bring me into the Anomaly Detector component. And then from there, we're going to go down here to Keys and Endpoint. And we're going to copy the endpoint, which is going to give a link to, in order to stream this data to the Anomaly Detector. So we'll go back over to this little website. We'll paste this endpoint in. Okay, now we got to have a key. So we'll jump back over here. We'll copy key number 1 here and paste that in. All right, and then from there, if we look down here, a couple things. They have a sensitivity simulated in client. So from 0 to 99, they tell you this is going to define how sensitive the backend API performs filtering on the results of anomaly detection. Adjust the sensitivity to see how it affects the anomaly, so how strict do you want it to be. Max detection window, so time-wise, This is going to find history points are used to detect current anomalies based on a series of times. So it'll look at it from 28 increments, and then maximum anomaly ratio. This will define the max percentage of anomalies in one direction. Now you can kind of play around with this and see what you get. But all this stuff could be adjusted if you're doing this through code, or if you were doing it through the Azure portal directly. You could adjust it. We're going to go ahead and hit start, and it's going to start playing through this data as though it was being streamed in real time. So this is actually simulating being streamed to your anomaly engine in real time right now, and you're getting current response information right here. So we're letting that run through. All right, so we'll give that just a moment. You can see we have one anomaly already showing up here, and we're about to get another one. All right, yep, and it's catching. So you're seeing that the engine, and remember, the engine is not looking at this graph. The engine is looking at numeric values that are included in the CSV file, the comma separated value data that's been collected. And you're seeing that the Azure engine is noticing these anomalies and catching these anomalies. All right, so I'm gonna go ahead and stop that. But if we go here, we can see anomaly was detected. All right, and you can see the spikes. See that it's detecting. Obviously it would detect an anomaly here, it's going to detect one here, so on and so forth. So it is providing that information within the detection window that we've got. There is a second sample you can check out. There's a third one here that can be checked out, but I'm just looking at this first one in this particular video. Okay, so in this example, I'm kind of picking up where I left off on this previous one. We had a univariate anomaly detector. We looked at that, and then now I want to look at multivariate. And in this scenario, we've been provided some data that's been collected from various objects here. So you have a optical L filtered, optical R filtered, pump pressure, rotational, and vibration horizon. Those are all things that have been collected. And we can now go right here and up at the top, and we can say train model. So it's going to grab all that data, and it's going to go through the training, and then from there we can say, okay, now let's start inference. All right, so we're going to go ahead and hit start on that. Now we can see the output here. So the variable data that was collected is this top area here based on CSV data that was collected. And then below here, you can see the anomalies. So you can see everything. If you look, it says normal, normal, normal. But then when we get right here at this particular time, you can see there's an anomaly. And then everything's normal. There's an anomaly here. There's an anomaly here. So again, this is actually taken this data. It's collected a bunch of the information from it. It's looked to see, like, based on the data that it's collected, what's normal, looking at the average amongst all of the different sensors that have been looked at. And then it looks for time periods where multiple sensors are showing some kind of abnormality. And that's how it's able to build this little graph for us. Now again, I know we're not looking at this from the Azure standpoint just yet inside Azure, but it is our engine here, this anomaly detector engine, this feature, this resource in Azure, that's actually what is providing us this information. So we're using this for grabbing the data and being able to process the data and all of that stuff. All right, this resource. So that is an example of a multivariate anomaly-based detection. Okay, I no longer need my anomaly detector in Azure. I don't want to keep it in there, waste resources, so I am going to go back over to portal.azure.com, and we'll go back into our, I'm going to go to resource groups by clicking the menu button, and I'm going to delete my little resource group here, which will also delete the anomaly demo there. So we'll go ahead and copy that name, paste that in, hit delete, and it will take just a moment, but it will then delete it, and I've gotten rid of that resource. Let's talk about computer vision workloads with Azure. So one of the common things that people utilize AI machine learning for is going to be dealing with pictures and video. And Azure has this capability and support. Now, I also want to point out that this video is not going to dive deep into the details of all of this. Stay tuned for that. This is just introducing you to some facts to be aware of. So as you can see here, analyzing this photo, AI has the ability to say, okay, well, we've got a man in a yellow apron cooking meat on a grill with a woman in the background, a person holding a spatula, a person wearing an apron. That's how it's able to determine this. A girl holding a hula hoop, a red ball with yellow flames on grass. So see how it's analyzing the different elements. It's pulling different elements, and then from that, you can imagine that with AI's machine learning, it can take all of these facts that it's gathered and sort of determine what's going on in this photo. All right. Now, if you actually do a quick Google or Bing search on just Azure's AI Vision, you'll come across this page here, and they give you kind of a breakdown of what you're getting. So it's a unified services, giving you the ability to analyze images and text, detect faces. It's got pre-built image tagging support. It's got OCR support, so it can actually read text, optical character recognition. So you can see here some of the benefits and features you're going to get. Image analysis pulls from over 10,000 concepts and objects for detecting, classifying, all of that. Spatial analysis, so it can determine, where are we at? Are we outside? Are we inside a building? Again, optical character, facial recognition, all of that is part of the concepts when you get this. Now, Microsoft also, if you do a Google Bing search on what is Azure AI Vision, you can see the breakdown. And this is really what I need you to take away from this video. There are 4 services involved in the Azure AI Vision. Okay, so this is the key. This is the key thing I need you to remember. First is OCR. That's optical character recognition, being able to extract text from the images that's being displayed. All right, and determine based on the text, what the writings are, and produce that information if need be. The next is image analysis, so the ability to extract the different visual features from an image. And again, the objects, the faces, children, adults, whatever it may be, and then provide a description of the different elements that it's seen. The next is, again, face. So looking at facial algorithms to detect and analyze human faces. Again, this gets down to things like somebody's happy, somebody's sad, somebody's angry, whatever it may be, but it should be able to grab that information. And then lastly, the spatial analysis. So that is determining what's going on in a picture or video. Is it outside? Is it inside? Is there movement going on? What exactly is happening? And so those are going to be your core 4 things when it comes to working with Azure's AI Vision. All right, and again, this video is just introducing you to this concept. We're not diving deep into it just yet. Okay, let's discuss natural language processing, also known as NLP, which is an acronym I would recommend that you try to remember. So another piece of the AI puzzle when it comes to working with machine learning and artificial intelligence is natural language processing, NLP. All right, so Microsoft does support various ways of doing this. One of the big ones that they utilize is Spark, which is this little graphic you're seeing over here. The idea of NLP is it's going to provide us a means of doing these various things you see here, like classifying documents. If we needed to label or provide some kind of sensitivity, or have a document that is discovered to be spam. Another thing would be looking and doing searches for us, summarizing text for identifying the entities that are present in a document. So maybe discovering like who's being talked about or mentioned in a certain document. You've got needing to tag documents if we need to tag those based on keywords. Another would be do content-based searches and retrieval. So, maybe we're looking for specific pieces of content in an email or text messages or inside of a document, whatever it may be. Summarize a document's importance based on the topics that are discussed in that document. Imagine a 500-page document and you need to categorize that based on some specific topics. This is going to be great for that. So categorizing for navigation, enumerating relating documents based on a topic. So that's going through, when they say enumeration, they're talking about basically processing each topic, looking through every topic and putting together a list of the various topics. Scoring text for sentiment. So is the tone of a document or email or whatever, is it happy? Is it positive? Is it negative? What's going on? Is there sensitive subjects being discussed in it? All of that is what you're going to get out of NLP. All right. So you can kind of see the breakdown here. This is sort of what Spark is based on. So entity recognition, information extraction, spelling and grammar, text classification, translation, summarization, questions and answers. So it's based on three main components here. You have the annotators, models, and languages. Okay. So annotators being the blue area here that you're seeing, being able to take data like text, split it up, checking for sentences, tokenizer, word segmentation, various things here. And I'm not going to dive deep into some of the stuff like the mGran generator and all that right now, but cleaning up text, understanding grammar, finding specific text. All right, you have all of that as part of the annotators. And then the model, so being able to actually model the data that's been collected, model the information, and analyze based on that. That's all part of this as well. So it's able to base everything, break it up into a model. These are some of the predefined pipeline and models that they can utilize. For when I say pipeline, you're taking various components in AI and connecting them to other components in AI. For example, I might have to, in order to grab the natural language processing, I actually have an image, so I might have to, send that through the image pieces of AI to be processed. Then it would grab, based on OCR, grab the data text. Then it runs into NLP, natural language processing. So that's when we're talking about pipelines, that's what we're talking about, and transformers and all of that. Of course, I'm not diving too deep into that in this video, just giving you a basic rundown. Then you've got, again, the various languages. So obviously part of this is knowing the various languages, having various languages that it can analyze. It doesn't do a whole lot of good if you're only able to do this in one language. So Microsoft is adding languages as time goes on to support this NLP capability. So this is the idea of natural language processing. In this video, I'm kind of just introducing you. We're not diving deep in this particular video. I just wanted to help you understand the concepts of what this is going to be used for. Now, one of the final methods that we have when it comes to Azure AI capabilities and features is a feature called knowledge mining. So knowledge mining is the concept of ingesting data, whether the data is structured data that's all in a certain order based on a database, or whether it's CSV, comma separated value, or it could be unstructured data. So this could be PDF file, image files, video files, audio files, and then from there, after we've ingested that information, we can perform other actions against the information. So we could enrich. So we're ingesting first, right? We're grabbing that information. From there, we are enriching or exploring, or both. With enriching, we have the ability to look at Azure Vision to analyze visual graphics through images or video. We have language capabilities for taking text and looking at language. We have speech. We can grab information from audio. From there, decisions can be made, searches can be made. We can translate data into other pieces of information and sort it, categorize it if we need to. And then from there, we can sort this information into a way to where it can be properly explored, whether this be some kind of business type data that we're using it for. This could be a CRM, customer relationship management database. It could be ERP, which is enterprise resource planning data. It could be RAP, which is risk assessment programs type systems. These are all systems that could utilize the data after it's been ingested and then enriched, right? And then we could explore it using these apps, search through it. We can manually search through it for keywords and all that, or it can also be used for things like analytics for Power BI. So again, that is the idea of knowledge mining, another feature and capability that Azure has for basically collecting all of this information, or ingesting it as it's called, then enriching it, which means we can grab that information and break it down into different pieces, analyze those different pieces, translate it if we need to a certain way, and then from there we can explore it and do what we need to with that information. Now, before you can really do a lot with Azure's AI machine learning, you have to have an Azure Machine Learning workspace. So this is going to be an area where you can actually pull information in and have your AI go through and run analysis against that data. So to start with all that, we are going to go ahead and go through the process of creating a Azure Machine Learning workspace. So here we are on portal.azure.com. We click the menu button, go to all services, and we're just going to do a quick search for machine learning. And then from there, we're going to look for Azure Machine Learning. So we're going to click that, and we're now going to go right here and click to create a new workspace. Okay, from there, it's going to ask us to create a resource group. So I'm just going to create a new resource group. I'm going to call this Azure ML RG for machine learning resource group. So we'll go ahead and do that, and then we'll give this a name. You can name this anything you want. So we'll just call this Machine Learning ML Demo ELP for exam lab practice. That's what I'm calling mine. All right, and then I'm going to put this in East US. That's going to be the region. Now you can create your own storage account for storing the information, your own key vault, your own application insights. All of that, you can change the name of it, or you can just use the default. I'm just going to use the default. So the storage account is going to store data related to this. Your key vault will store encryption keys, secret keys, and all of that that'll be involved in this. And your application insights, this is what's going to be providing monitoring services and all of that. So I'm not going to dive deep into that right now, but we will need those. The last thing is a container registry. So this is going to be a register area for where we're going to store images like Docker images and any kind of deployment. This is going to be a container for those deployments. All right, so that's the idea of a container registry. So we'll just click to create. All right, I'm just going to call this my Azure ML container, and we'll put ELP on the end of it for exam lab practice. Verified it's there. There are various SKUs of basic, standard, and premium. You can learn more about the various SKUs that are available here. So I'm not going to dive too deep into that right now, but you can see the various SKUs, and there are some different offerings for that. We don't really need to dive into that right now, but I'm going to hit save. I'm going to click networking, and we want to make sure public is accessible. That means we can interact with all this across the internet and all that fun stuff. And I'm not gonna go any further into any of that right now. I'm just gonna click review and create. All right, and once that's done validating, we're gonna go ahead and click to create. So we'll give that just a moment. I'll just pause my recording while that's being created. All right, so as you can see, it's done, and if I click go to resource, it's gonna bring me right into the Azure Machine Learning workspace. If we go to the resource group, Azure ML RG, which is what I called it, you can see that we have all these various components, these resources that make this up. All right, so you'll see quite a few things, but the main thing that we care about right now is the Azure Machine Learning workspace. So now that that is set up, we are ready to move on. Now, before you can really dive in and start working with machine learning and all that in regards to regression, it's kind of important to know what it actually is. So I want to take a moment here and make sure you're aware of what machine learning regression is, okay? So what is it? Well, the idea of machine learning regression is to provide a way where we can investigate the relationship between independent variables or features and a dependent variable or outcome. All right, so what exactly does that mean? Well, if you think about it like this, all right, we're trying to have a predictable model. So we want AI to try to predict the outcome regarding things like sales or the chances something might break or something along those lines. The sky's the limit. You can think of lots of ideas here. The example that we have on the screen here is a coffee shop, okay, or a series of multiple coffee shops, maybe not just one coffee shop. But you can see we have over here our dependent variable. This is actual facts that we are going to feed into the machine, the AI machine, the machine learning component, right? Cups of coffee sold, and we've got from 0 up to 350 cups, okay? And then the time of day. And again, this could be one coffee shop, this could be two coffee shops. At this point, it really doesn't matter. All right. Now you can see the coffee sales are the red dots here that you're seeing, and you can see approximately what time that's happening at. So you're going to notice that it seems like as we get into this time period here, we're getting lots and lots of sales. As time goes on, things go down. Okay, so you got this line here representing the actual trend, right? In the morning, it starts picking up, get to about 9 a.m. As time goes on later in the day, we're going down. All right, at this point, we're at like 2 p.m. in the afternoon. Okay, so we've gathered these metrics. We've gathered this data from maybe our cash register software, POS software, point of sale software, or whatever. We've grabbed all this analytic data, all right, and we've discovered exactly what time of day the sales occurred, right? We know what the actual trend is, and we can see that there is a linear trend. This is just a downward straight line that's representing, throughout the day that ultimately you have you're starting to not sell as much later in the day. And in some cases, you'll have, depending upon what you're working with, you'll have an up line, an upward line, where things are going up as the day goes on. All right. But ultimately, the idea here, why is this valuable? Because we can take this data and feed this through our Azure Learning Machine here for regression testing, and it can build a model for prediction. And generally, what can happen is we can take 100% of our data here, and we'll take 70% of that 100%, and it'll build its model on that, and then we'll test the other 30% against the actual machine to see how well it scores in terms of the outcome. And so the idea being that based on this data, a coffee shop, for example, could predict what their sales are going to be each month, what their sales will be tomorrow. Of course, there's other variables like the times of year and holidays and all of that, but with enough data, we can have a pretty good prediction on sales, how much money's coming in for that coffee shop. And again, this is just an example. You can imagine we could do this with a lot of things. We could do this with car sales or inventory. There's so many different options, but just using this example, we are able to build a model for predicting, or I should say the AI is going to help us predict what we should expect in the future outcome. So hopefully that gives you a better understanding now of just what this machine learning regression is. In this video, we're going to learn how we can utilize regression machine learning to help us discover certain values from a data set that is entered into our workspace. So here we are on portal.azure.com. If we go to the menu button, go to all services, we can search for machine learning, and we'll go to our Azure Machine Learning here, and that'll bring us over here. And we've got our workspace, which I have called the ML Demo ELP. So we're going to go into that. All right. Once we get into our Azure Machine Learning workspace, the next step is going to go into the studio, which is what's going to allow us to interact with our machine learning engine. So we're going to open up Launch. We're going to click on Launch Studio. All right, and then from there, we are going to go right here to the designers. So this is the starting point where we're going to begin, and this is going to let us start figuring out what data set we want to utilize and what exactly we're trying to accomplish. So we're going to go over here to Designer. All right. And the first step is to create a pipeline. All right. Now, a pipeline is going to be a series of functions that you want this artificial intelligence machine learning engine to perform. One might be just to grab the data that you want to grab, and then you want it to sort the data a certain way. You might want it to clean up the data before actually performing some type of analysis. So the idea of a pipeline is, think of it as a series of steps that's got to happen for this to work. And the best analogy I can give you to that is sort of like a factory. If you think about a factory, how you imagine you've got some object that's going down a conveyor belt, and you got one person that does something to that object. That's one part of the pipeline. Well, then the object continues going down the conveyor belt until another person does another thing to it, adds another component or changes something about it, and then it goes down the pipeline again, or it keeps going down the conveyor belt, and then another person changes it in some way until finally it gets to the end. It's the finished product. That's the idea of a pipeline. All right. So think about it like that when you want to try to wrap your brain around pipelines. So we're going to click on Create a New Pipeline. All right. So that'll bring us into an area where we can start creating a pipeline. Now, one of the great things that Microsoft provides us with is a bunch of sample data that we can play around with, and it gives us a perfect opportunity to learn this. So we're going to expand sample data here. All right, and I think I'm going to go with this automotive price data. So the idea is cleaning missing data module required. So we're going to want to clean some data and then figure out the price point information about the models of vehicles that they've got. So we're just going to drag that over here. All right. Then the first thing we want to do is we're just going to look at the raw data, and it mentions clean missing data. So if we right click that and we click preview data, all right, that's going to give us an opportunity to view the data. I'm just going to expand this out. We're going to maximize the panel. All right, and we can see all of the various columns that we've got here. All right, now right out of the gates, take a look. As we click on these, you'll see missing values. With this one, where there's no missing values, normalize. Okay, so there is some missing values under normalized losses. No missing values under make, fuel type. We just kind of click through these. Okay, number of doors, couple of missing values, drive wheels, so on and so forth. No missing values. As we move through, it looks like there are 3 columns so far that has missing values. Now, it's important if you're going to, okay, here we got some others with some missing values, bore and stroke. We might not even need those columns, though, if we're not going to run those through the engine. We don't have to run all of this data through the engine if we don't want to. All right, so horsepower is a couple missing values. All right, now price. Now, price is going to be one of the key elements that we're going to run this analysis against, so we definitely want to clear any missing values there. It's important to get rid of missing values if you are going to get a proper model put together for being able to make predictions with regression testing. So we want to make sure we remove that. So let's go ahead and we're going to keep going with our pipeline and see how all this is going to work. All right, so we're just going to minimize that. All right, and we'll just close out of that. All right, so here we are back on our pipeline. So the next part of the pipeline that I want to add is going to involve selecting data. All right, so here we are back here on Asset Library. All right, and I'm just going to search for the keyword select. All right, and we're looking for selecting our columns in a data set. So this is it right here. We're going to drag and drop that right here. And so we're going to connect the pipelines together. So we have this output. We're going to drag and drop that onto the input of our data set. So the raw data is going to flow into this select columns in data set. We're going to double click on that. Okay, double click. And then we want to select our columns and all of that, but there's a couple things to consider here when it comes to working with this. Namely, when we are going to be working, you can kind of branch this out and sort of look at some of the various options that we have and all of that, run settings and all that. And actually, run settings is the thing I want to talk about, but you've got node information. So what is all this? Well, this involves a node is going to involve a virtual machine that's going to involve the processing power that's going to do the job that we need done. So we got to specify a compute target, a virtual machine node that's going to do this. So if we go right here, it says change default compute target. All right, it says please select a default compute target. We're not going to do a cluster right now. We're going to go with just a compute instance because this isn't really a large amount of data we're needing computed. Problem is we don't have a virtual machine Azure Machine Learning compute instance that can do this. So we're going to say create one. All right. So wait on that to load up. This is going to allow us to go ahead and add the compute instance. Okay, so we can specify the virtual machine type. You can give it a name if you want. CPU, GPU, central processing unit, graphical processing unit. In our case, we're not really doing anything that's going to cause need a lot of graphical mathematics. So we're just going to do CPU. You can choose which of these you want to go with. They have a recommended one here. So 29 cents, 10 cores, that's per hour. I'm just going to go ahead and go with that. So we'll go ahead and click review and create. All right, so 32 gigs of RAM, 150 gig of storage. It'll auto shut down after 60 minutes. So that's really great. You don't have to worry about this like staying on for long periods of time unless you need it to. We are going to allow that auto shutdown. All right. So from there, we're going to go ahead and click to create. All right. Now, of course, you got to be a little bit patient with this. This will take a minute before it's fully up and running. Okay. So just be advised that right now, when I try to select my image, it's not letting me select that. So I'm going to just pause the video for just a moment and give this time to process through, let it finish creating, and we'll keep going. Okay, so now you'll notice that it says running. We're just going to go ahead and select that. We're ready to click review and submit. Okay, and let's just make sure we haven't missed anything. All right, so it's telling us basic job name. Yeah. Select experiment. So we'll create a new experiment. All right, and we'll just call this ELP automotive data set. That's going to be the name. That's fine. I'll take all the other values there. And now I think we're ready to review and submit. I did forget to give it a name, but there we go. Now that we've done that, we're ready to submit. Okay. And excellent. So the next step is we're ready to select the column. So in other words, we have that raw data that we've grabbed. What are the columns that we actually want to run this raw data, run this analysis against, the machine learning analysis? We may not want all the columns, right? So we can edit the columns and specify the columns that we want. Okay. So right here, again, I can choose which ones I want. All right, maybe I don't want all of them, so we'll just do a few. We're going to do normalize losses. We'll do make. How about fuel type? Number of doors. Let's see. How about number of cylinders? Let's do engine size. Let's do highway miles per gallon, and then of course one of the critical ones we need is price, because we're going to run, part of the analysis is going to be to try to part of the goal here is to have it guess what the price is going to be based off of all of these factors. Okay, so that's going to be what we're going to select. We're going to go ahead and hit save, and we've now got our information. We've got it saved. Everything's good there. So we'll close out of that, and we've got that part of our pipeline configured. Now, if you recall, if we go back over here to preview data, we've got some missing values, and that's very important. I think of all the ones that we selected, I think normalized losses has some missing values, and price. I think of all the ones we selected, those are the ones that have the missing values. So we definitely want to clean that up. All right. Now we're going to go over here, and we are going to add a component to our pipeline that's going to do that for us. So we're going to go over here to this little symbol here, the asset library. We're going to search for the keyword missing. All right, and we're going to look for clean missing data. So we're going to drag that down here. We'll drag and drop that, or connect it, I should say, from the output to the input. And then now we're going to double click on this, and we're going to specify the columns. So again, let's go back and verify. You definitely don't want to have a typo here. I have made that mistake where I have put a typo in there and it didn't work. I've also made the mistake of not understanding that it is case sensitive. It is case sensitive. So if you're dealing with all lowercase, you need to make sure you do all lowercase. Okay, so let's go back over here. Let's preview the data again. It's normalized dash losses. So that's what we want to put, right? So we'll double click on that. All right. Unfortunately, it doesn't just detect the columns. So normalized dash losses. All right. So at that point, we've got that. Close out of that. Now we also have to worry about price, and you are going to have to add another one of those for that one in this case. So put that right there. All right. Double click on it, and it's just price. Make sure there's no capitalization. All right. And at that point, we've got all of that ready to go. All right. So we can save that. Now, if we wanted to, we could also, if we double click on these, we can also, you can substitute or you can replace values. So like right now it's replacing any missing data with a 0, but if you wanted to replace it with some other value, you could totally do that. All right. So that is something you can utilize with this missing data. All right. So from there, you can validate it if you want. Pipeline looks good. There's no errors. If we wanted to go ahead and submit this, we could say configure and submit, and it would actually go through and pull the results as things are right now. Again, we're not really doing any prediction here. We would just be purely looking at what happens when we've ran it through and it takes care of those missing values. So we can hit submit, and at that point it is going to go through the pipeline. It's submitted. It's in the process of loading. I'll pause the video while that's happening. Okay, I believe it's done processing now. So we're going to go right up here where it says View Details. All right, and if everything's done, we should get some check marks next to all of the components in the pipeline. So that's what we want to look for, is the little green check marks. All right, and it looks like everything is checked off. So that means that everything successfully did run in the pipeline. Let's look at our final results here. So we're going to right-click the last component here, preview data, cleaned data set. We'll maximize that up. All right. And so exactly what we want to do. So the values that were originally missing have just been set to 0. All right. So you'll notice that it was able to successfully replace the missing values that were just null with 0. All right. And you'll see that it's only showing the columns that we selected. All right. So this is just part of the process. And we've now got a clean data set. All right. Now, one thing I will kind of warn you, a lot of times when people get inside this spot here, they really don't know how to get back to where they were. Well, if you look, we are on jobs right now. So we're looking at things that we've processed through. What we want to do is go back over to Designer and then click on our pipeline. And then that is going to bring us right back in here where we can continue working with our pipeline. And we're going to pick that up in this next video. In this video, we're going to go in and we're going to start finalizing our regression machine learning pipeline. We're going to have it train a model. So we're going to have it analyze our data that we have. It's going to train with that information so that it can build a prediction model, all right, that will basically allow it to predict what the price is going to be based on certain factors of an automobile. So let's get started. Here we are on portal.azure.com. Go into the menu button, go to all services, and I'm just going to search for machine learning. We'll look for Azure Machine Learning. We'll go into that. We'll open up our workspace that we have here. Once we get into the workspace, I'm going to go into Launch Studio. Once we get into the studio, we're now going to go over to the designer. And we've got a pipeline already set up, so we're going to open up that pipeline, and we're now ready to get started. So right now we're taking the automobile data, looking at certain columns, and we're cleaning up missing data, basically changing the values to 0. So it doesn't have any null data, any missing data. All right. So the next step is we're going to split the data. So we're going to go through and do a split. So we're just going to search for split. All right, we'll look for split data. So it's going to partition the data, the rows of data, into 2 distinct data sets. So we'll select that. All right, we're going to collect our, we're basically going to connect our output clean data to this data set here for splitting. All right, and don't worry, this is going to make more sense as we get a little deeper. So just bear with me. If you're still a little bit confused, just hold tight for just a minute. All right, now we're going to train. So it's going to basically analyze data, and it's going to train from that data. All right, so we're going to search, and we're going to look for, let's clear that out, and search for train model. There it is. We'll move that right here. Okay. We're going to take the results from split data. We're going to connect it to the data set, and then we have to have a training model to go off of, and we're going to use what's called linear. So let's find that, linear regression. So this is going to create a linear regression model. What is that? Well, that's the idea of having one specific value you're trying to get from a series of different variables, and you're figuring out what the linear regression is going to be of that. All right, so we're going to just put that one, we'll just move that right here. All right, and we're going to connect that to there, just like you see there. And then finally, let's scroll down. There we go. And by the way, you can double click on these, and there are various values that you can look at when you double click on these. And we'll take a deeper look at some of that here coming up in just a moment. All right. So bear with me, and we'll look at some of that. Don't want to get ahead of myself just yet here. Okay, the last thing I want to do, I want to throw a component in there for scoring. So it's going to analyze, it's going to run its own test, and it's going to score itself based on predictions. And our goal is to make it go ahead and learn from 70% of the data. So it's going to take 70% of the data and learn from that. And then it's going to score itself from 30%. The remaining 30% of the data, it's going to score itself to see how well it does. That is the idea of the model here. All right, so we're going to go up here and we're going to search for score, and we got score model. We'll drop that right here. Okay, we're going to connect the train model there. All right, and then from there we're going to take the split data and connect it right here to the data set. Now, why are we doing that? Well, the split data, if we double click on that, right now it's going to do 50-50. We're going to change that 0.5 to 0.7. All right. So essentially that means it's going to train with the first 70%, and the remaining, whatever's left, which would be 30%, it's going to test itself and score itself. So that's the reason we did that. All right. So we've got our various components now in here. Now there's one final piece that a lot of times people forget when they set up a pipeline, and it's kind of a critical piece because it's the evaluation piece of the pipeline. So you're going to be able to evaluate the information that's been gained by the pipeline. So we're going to go right here to score, and we're going to search for evaluate. All right, evaluate the model. Let's move this down a little bit, and we'll drag that right here, and we're going to connect these two together. Okay, so excellent. Now the key thing we need to do is, you'll notice there's a little warning symbol over where it says train model. That is letting us know that we have not specified what we're actually looking for in these results. All right, because the model is being trained to find and predict based on some value. In our case, we want to predict based on price. So we're going to double click on that. We're going to click Edit Column, and we're going to put in price. Make sure it's lowercase, and we're going to click Save. So at that point, we have entered in the information that we want to train this on. It's going to train against 70%, right? Because it is, if you go and look at the split, it's 70%. It's going to train based on that. It's going to score itself based on the 30 remaining percent. All right, and that's what it's basically training off of. It's going to do a linear progression. So it's looking at this from the angle of price versus all the other parameters, and it's trying to figure out a prediction based on price. And then we've got scoring to see how well it does, and then we've got evaluate the model, which is the key piece that lets us perform evaluation. We're now ready to save this, and we're just going to validate it to make sure there's no errors. Okay, so we validated it. The pipeline looks good. All right, so everything looks solid there. We're going to go right here to this ellipse symbol, and we're going to click Configure and Submit. All right, we can specify the name, create a new experiment, specify the name of the experiment, just existing one if we want. We can click Review and Submit, and we're going to click Submit. All right, I am now going to go ahead and let this process through, and in our next video we will evaluate the results. So in our previous lesson, we created our pipeline to take some data from a sample data set involving automotives, right? We wanted it to run a predictive analysis, basically regression machine learning, to try to determine how well it could predict the price based on various variables of that data set that we've gathered. So we want to look and see how we can kind of evaluate the results. Now I do kind of want to warn you, the sample data we've had is not a very large amount of data. So it only had so many columns and all that to learn from. So its predictive analysis and all that isn't as great because there's not as much data for it to analyze. But you'll get an idea of why this would be beneficial, especially if you had a large amount of data to go off of. So here we are on portal.azure.com. We'll go into the menu button, go to All Services. We'll just search for Machine Learning. We're going to go into Azure Machine Learning, and then from there we'll open up our workspace. And then once we get in the workspace, we'll open up the Studio, Launch Studio. All right, and this time we're not going to go to Designer because we've already done the designing side of it. We're going to go to Jobs because it processed through earlier. Of course, when you did this earlier, you could have also just clicked View Job, View Data. But we'll go right here. Here's our job, our pipeline. This is the latest and greatest one we've ran through, so that very first one. And everything should show green check marks if everything went through successfully. And so as you can see, the pipeline, everything in the pipeline went through successfully, including the evaluate your results. We're going to, first we'll take a look at the score, right-click the score. We'll click on Preview Scored Data. All right, maximize that up. You can see the information that it gathered. and it's basically scoring itself on how well it would predict based on these facts. Now, it's giving you this mean number here, and I'll explain what that is in just a second. But you can see the information that it's able to gain here. All right, and we'll talk a little bit about making heads or tails of that. But that's the scored data. Now let's look at the actual evaluation. So we'll go over here to Evaluate Model. Click on Preview Data, Evaluation Results. We'll maximize that up on the screen. Now here is the information you get. Now if you go to Google or Bing and you do a search for metrics of regression models in Azure, you can find this little model here. In fact, I'll show you the search result. So Evaluate Model Component, you can do that. Azure Evaluate Model Component, any of those keywords, and you'll find this article right here. And what we want to look at, because we're talking about regression here, is look for the section for metrics for regression. So you'll see these items here. You have the mean absolute error. This measures how close the predictions are to the actual outcomes. They tell you the lower score is better. Now, again, when you are not dealing with a lot of results, you're going to have not great scores. You're going to have numbers that are in the tens of thousands range. That's the amount of error checking and all of that is doing. So the higher the number, the worse the results. The lower the number, the better results. But the more data you've got, the lower those numbers usually will be. Considering we don't have a lot of data, when we look at our results, we got pretty large numbers in the 2,702 range here, and then you can see these other values also. We're only evaluating this against one unique value, which is price. Okay, so we have the mean absolute error, root mean squared, creates a single value that summarizes the error in the model by squaring the difference. You have relative absolute error, which is absolute difference between expected and actual value. The relative squared error, which normalizes the total squared error of the predicted values, and the coefficient of determination. So these are the various values that you can sort of look at, and I would kind of, if I were you, I would just know the definition of at least these four right here. You don't have to be an expert on this for what we're doing here. You don't have to be a math whiz or any of that, but you should probably check out this little article, Evaluate Model Component, and then just make sure you get these little definitions down. All right. But all in all, that is where we're getting our values, and that is how we're able to create the pipeline and evaluate what the end results are. We want to see low numbers, though, when it comes to this one right here. Let's discuss the concepts now of what classification machine learning is. Now, in this little drawing, I just wanted to make it as simple as I could before we get deeper in what this is. So what exactly is classification machine learning used for? Well, the idea of this type of machine learning is to try and predict the category or class that an object or an item belongs to. This can be done in like a binary fashion type scenario or multi-class scenario. You've got, in other words, with binary, you've got, you know, a single variable really you're kind of focusing on here, or lots of different variables that's going to help you predict how many of a certain type of object there is, or what class, what category, I should say, those objects belong to. Now, with that said, let's just look at my simplistic example here. So you're going to see over here, I've got on this side, I've got three different symbols. I've got circles, squares, and triangles. Now imagine a data set that wasn't involving images like this, but what if it was just pure text, right? So, you know, you've got circles that are blue, squares that are red, stars that are yellow, but you've also got some that don't follow suit with that color. You'll notice that most of them are blue, most of the circles are blue, most of the squares are red, most of the stars are yellow, but we do have some that aren't. One square, for example, is black, one star is green, another star is orange over here, and then we've got, you know, some purple circles. So we've got some data that we would need to analyze and maybe say, okay, we want to categorize it, but there are certain pieces of data perhaps that don't always match. And that's kind of the point I'm trying to get at. So if you look here, if we wanted to categorize these objects, circles, stars, or squares, if we needed to know like how many circles are there, how many squares are there, how many stars are there, but just based on the facts, not the visuals, okay? So some of the variables that could be analyzed in this data set would be points of the object. How many points are there on the object? Is there any points on the object, right? With our squares, we've got 4 points, right? With our star, we've got 1, 2, 3, 4 points there, but then inside, we've got 1, 2, 3, 4, and 5, right? So we've got lots of points on a star. And there's no points on the circle. So anyway, those are our points, and then you got straight surfaces on the object. You know, how many straight surfaces are there? Curvature of the object, okay? And then color of the object. And again, the color of the object you can average. So the idea would be if you collected all this data and you ran this through a machine learning engine, right? A classification machine learning engine, okay, like in Azure. At what point, could you just simply give one of these data points and have it classify, right? With the points on an object, that would be a very effective way to do it. With straight surfaces, that would be a pretty effective way to do it. Curvature, color would probably be the least effective just because it's not always the same exact color. But my point is that imagine a scenario where you got lots of variables. Like I think a good scenario here is what if you had a machine learning engine that was trying to predict diabetes for a certain age group of people. So imagine if you had all this medical data on, so let's say people in the United States. It might even be a certain region of the United States, and you've got things like their age, their weight. You get into the sex of the person. You get into have they had any medical issues related to their weight in the past? Has this person had a child before? So you had all this data, and you wanted to predict whether or not these people would get diabetes based on a certain set of variables. That's the idea. So you could say, well, this person would belong to a category or a class of people that probably will get diabetes. You're using this model to predict something based on that. All right. So with our object data set here, we could categorize a bunch of objects. We could see, well, how many stars, how many circles, how many squares, and then based on more variables that get thrown into the mix, we need to categorize those based on our information. So the more symbols we have based on the number of points, so based on the color, we can guess how many would be squares, how many would be circles, how many would be stars. So that is the idea of a classification machine learning engine when it comes to our AI system. And hopefully now you have a better understanding at least of what classification machine learning engines are used for. I now want to get into how we can utilize a classification machine learning model. All right. So here we are on portal.azure.com. Just going to quickly go here to the menu button, go to all services. We're going to go and do a search for machine learning. And I'm going to create a new machine learning workspace here. So I'm going to click to create new workspace. All right. A new resource group. It's going to call this ML classification. And I'm going to click OK. We'll call this ML classification demo. That'll be the name, and East US will be my region. I'm going to go with the storage account, key vault, application insights. Just going to leave all that alone. I'm going to create a new registry. I'm just going to call this ML class registry. I like to keep things separated into different containers and different workspaces for the demos I'm doing. So I'm going to click Review and Create, And once that's done validating, I'm going to click create, and I'll just go ahead and pause the recording while that's being created. Now that that's done, we're going to click go to resource, and we're ready to go into the studio. So we're going to click launch studio, and that's going to bring us into the machine learning studio. Now let's go over to the designer, and they have some built-in pre-built options here, image classification, all that, but I'm actually going to use we're going to build a custom pipeline here. So we're going to go right here, create a new pipeline, and from there we're going to use some sample data. We'll just go with this very first one, which is the adult census income binary classification. So we'll just drag that over. All right, we've got our data set here that we're starting with. We'll right click it, and we're going to click preview data. And then from there, we can see the information that's available in this data set. So you can see the age, the working class, all of that stuff, all the way here to income. And ultimately, income is what we're going to focus on. We're going to focus on being able to predict based on the various variables that we have here. We would want to predict perhaps if somebody is making less than or equal to 50K or maybe more than 50K based on the information. So we're going to classify people based on income, based on the variables that you see here. Now, one thing we want to look at is look at the different columns, and we want to look for any kind of errors. For example, if we're looking at age, we want to be thinking about, well, you know, the minimum is 17, so that's when it's tracking the beginning, and then maybe the maximum is 90. You wouldn't want that to say like maximum of 500 or something, right? Because somebody's not going to be 500 years old. So we're going to look at that. The other big one to look at is missing values. We don't want any missing values. So as we look through, you want to make sure that whatever columns you're pulling, you don't want missing values. In this case, working class, we've got some missing values there. All right. So we want to clean any missing values. Of course, we might not even pull work class in as a column, so it may not even matter. But right now, we've got all of these columns we'd have to consider. So we just want to be looking at making sure there's no missing values. So we now officially have our data set, and we're ready to continue building our pipeline. Now what I want to do is I want to take this data from the data set, and I want to split it up into a 70-30 analysis. And the idea being here that we're gonna train our machine learning engine using 70% of the data, and then we can test it and score it based on the remaining 30%. So to do that, we're going to come back over here to our asset library. We are going to search for the word split, and we're going to look for split data. So we'll drag that down right here, and we're going to connect the data sets here, the data output of the data, into this split data. All right. Now we're going to double click on that, and right here currently it would split it 50-50, but I want to change that to 70. All right. And then I'm going to hit save on that, and we'll just close out of that. So basically 70% will come out here for testing, and then we'll have 30% that will actually be used for scoring. All right. And that will let us know how well our machine learning engine is able to build its model for prediction and the classification and prediction and all of that. All right. So that is what we're doing with split data. Now, anytime you want to run a pipeline, you do have to have a compute instance, which again is just a virtual machine that's going to be utilized. And if I go down here to compute, I can click to create a new compute instance, and I have various methods I can go with here. If I'm just going to do a CPU or GPU, I'm not doing anything with graphics. I'm not going to use graphics processor unit. I can go with the default virtual machine size here if I want. Click next, specify a shutdown after 60 minutes. I can specify some other variables. I'm not really going to get into those right now, but I could create my compute instance that way. Another way that this can happen, which is probably the easier way when you're just wanting to create a compute instance for one particular project. If I go back over here to Designer, click on my project here, if I double click on split data, because that's where we have to have the compute instance because we are performing some actions against the data, we'll double click on it and we'll go right down here to run settings, and you'll see it says use default computer target, change default computer target. If we click that, you'll see that we don't have a compute instance, so it gives us the opportunity to create one. You can do a compute instance or a cluster, Kubernetes compute, attached compute. I'm not going to dive into all of that right now. I will say that we just need one virtual machine for what we're doing here. It's not an insane amount of data. We don't need a super fast response. So we're just going to go with a single instance. We can click to create one. It's going to bring that same wizard up that you just saw, right? So from there, I'll just click review and create. We'll click create, and it's now going to go through the process of doing that. And you'll see it is creating. Now this will take just a few minutes. I'm going to go ahead and pause the recording while that's being created. Now that that's done, we can select our compute instance there. And let's go back over here to where it says basics. We're going to give it a experiment name. Just going to call it split data. We'll click review and submit. Okay, that's all great. And we're going to go ahead and click submit. All right. So that's all good, and we've got everything set up for splitting the data. Why don't we go ahead and run the pipeline? All right, and it's taken just a few minutes to do that. While this is running. And by the way, when I configured and submitted, that's what triggered the pipeline to run. So we're running the pipeline, and then I'm just going to pause the recording and let that finish running. Okay, now that I've given that enough time, I should be able to click on View Details, and what we're looking for is green check marks to let us know that it has been completed. Notice that we move from Designer to Jobs now. All right, and you can see, there we go, there is a green check mark, so that means the job is done. So let's go ahead and view the information. So we'll right-click that, we're going to click Preview Data. Now notice that there is a results dataset 1 and a result dataset 2. Result dataset 1 should be 70% of the data. That's what we're splitting, right? And then result set 2 should be 30%. So we'll go ahead and click that. Here's our result set 1. That's, you'll see we got the 27,793 rows, 15 columns. All right, and then if we go back over and look at result set 2, we will notice that we've got 9,768. All right, so result set 1, result set 2, and as you can see, our split pipeline did run successfully, so everything's good there. Now we can jump back over to the Designer and open back up our pipeline here, and that'll bring us right back in so we can continue the work we want to perform on this pipeline. Now we're ready to add a train model component to this, which is going to allow us to allow our machine learning to actually learn something and go through the training process. So the first thing we'll do, we'll come over here under our asset library. We're going to search for the keyword train and look for, let's scroll down, there it is, train model. So we'll just drag and drop that right here. Okay. Then what we want to do is we want to take our results, the 70% results, connect that to the data set here. Now we want to know if this is going to be, the whole point of this would be to discover, is the pay going to be less than 50K or greater than 50K? So what we're going to need is a way to break this up into two different classes of logistical information. So we're going to actually come over here and we're going to search for to class. Let's search for that, and we'll look at, there it is, to class logistic regression. So we're going to drag and drop that right here, okay? And then from there, we are going to connect this untrained model data to right here to this untrained model. So we have a output input connection here between these two. Now, in thinking about the training our model here, you'll see the little warning symbol. And the reason why we've got that is because we haven't actually told it how, we're going to train it for classifying. And really what we want to think about here is income. If you go back over to your original data and you click preview the data, you might remember that one of our columns, we scroll back over here, one of our columns is income. We want to make sure we remember how that's spelled. It's all lowercase. And from there, we're going to double click on train model, go to label column, and we're going to put in income. So that's going to be the thing that we're training against here. So then the next thing we're going to do is we are going to want to score that data. All right. So what we're going to do is come over here to score. We're going to score the data based on the training. So we'll go to score model, drag this down here like this. Okay. And we're going to connect the train model right here to train model on score, and then we're going to take the results. Remember, it's 70-30, right? So 70% is going here versus the 30%. So we'll drag that down to here, all right, for our split data. So that's 70-30. And so now we've got our score model set up. Now the last part of the pipeline is going to be to evaluate the results. So we'll come over here. We'll search for eval, all right, and then look for evaluate model. We'll drag and drop that right here. We're going to take our scored data set, connect that right here, and we are now officially ready. Let's go ahead and just validate, make sure there's no errors. Looks good, everything looks good. So we'll save it, and we are now ready to submit and see what results we get. So we'll click configure and submit, all right. We'll use our existing experiment here, and we'll click review and submit. It's going to use the existing compute instance as well, the virtual machine that's going to perform the processing, and we'll click submit. All right, so at this time, I'll go ahead and pause the recording while this gets done. It'll take just a few minutes. All right, our job should be done by now, so we're just going to click on view details. That's going to bring us from the designer into where it says jobs here. And you can see we've got a green check mark over everything, so that's good. Now let's look at our evaluated results here. We'll right click and we're going to click on preview data evaluation results. We'll maximize this up on the screen. So the first thing you're going to notice is we have some various graphs right here. Now if you go to Google or Bing and you search for evaluate automated machine learning experiment results, Microsoft will help you understand these various graphs. So if we scroll down a little bit here, you can see the ROC, and they tell you the ROC curve. They tell you the receiver operator characteristics curve plots the relationship between true positive and false positive. Now I'm going to explain this whole true positive, false positive more in just a moment. All right. So that was your first one. You've got precision recall curve, lift curve, all of that. So if we come back over here, scroll down a little bit more, precision recall curve, they tell you this is going to plot the relationship between precision and recall as the decision threshold changes. And they basically tell you that recall is the ability of a model to detect all positive samples, and precision is the ability of a model to avoid labeling negative samples. Then if we take a look at cumulative gains, they tell you the cumulative gains curve plots the percent of positive samples correctly classified. And then finally lift. The lift curve shows how many times better a model performs compared to a random model. All right, you don't have to be an expert on all of this for what we're doing here, but I did want to give you a little bit more information if you want to look into that. So there's what you've got here. Now, most importantly, what we want to look at is the confusion matrix right here. So I want to analyze that. If you go out to Google or Bing and just do a quick search on confusion matrix, all right, machine learning, let's see. So here's a really good image actually. We'll open that up. I'll make that bigger up on my screen here. So you'll see the different categories here. This first one, the green ones are generally good things. So you've got the first one here being positive, and it's positive. So that means it detected it. It's a true positive, meaning it detected it, and it's saying that the result was positive. And then you have true negative means it predicted that it was a negative value, but it was it's a true negative, so it got it right. These two things are, hey, I got it right. And then you've got false positive. The prediction value is positive but it's true, so it predicted that it was positive, but it was actually negative. And then over here, the predicted value is negative, but it's positive. So that's what you're actually looking at when you are looking at this little matrix right here. All right. So you can see out of the results, you can see how many results it got wrong versus how many it got right. And you're going to see, of course, that it did get more right in the results than it did wrong. So the 1,388 plus the 6,889 is how many it got right. 927 plus 564 is how many it got wrong. Okay, based on the greater than 50,000, less than 50,000. All right. So that is how we can take a look at our score on this. And again, you don't necessarily have to be, for what we're to learn here, you don't have to be an expert on all these stats or a math wizard or any of that. This is just giving you a look at this evaluation. If you want to learn more, though, make sure you go back and you analyze. You can read through this article on evaluating automated learning experiment results and all that. But you really don't have to dive that deep into what we're learning here. But hopefully that gives you a much better understanding now of utilizing a classification machine learning engine in Azure. I want to spend a little bit more time helping you understand how to label a confusion matrix, whether it's true positive, true negative, false positive, false negative. And because that's one of the things that can be confusing, but you definitely need to have an understanding of it. All right. So I've got two examples here for you, and the numbers are the same in the examples, but some of the true or false information in here is going to work differently based on how things are labeled. And I want to make sure we understand true positive, true negative, false positive, false negative, and which of these blocks would fall into each one of these categories. Okay. So the way that you want to look at this, the way you figure this out, is always focus on the word actual versus predicted. Actual versus predicted. That's the starting point. And the way I always work these out is I work out my true positive and true negative first, because those are always the easiest to get. And note that this first example, everything's labeled with either a 1 or 0. So 1 or 0, 1, 0. So 1 is the word true, 0 is going to be the word false. That's the idea, or negative. So true or positive, false or negative, right? So the way to look at this is very simple. True positive is always going to be two trues together or two positives together. So a 1 and a 1. Start with actual. So 1 and 1, that's going to be a true positive. So I'm going to label that true positive. Okay. And then find true negative. That's always zeros together. Okay. Zeros together is going to be your true negative. So this 0 here, this 0 here, that's going to be a true negative. So let me copy that and we'll label that right here. Okay, so the next part is we got to find our false positive and our false negative. So what you want to remember always is that when you don't have two numbers together, it's all the first word is always going to be false. So if you don't have two ones together or two zeros together, then it's always going to be a false. So it's going to start with the word false. So that leaves these two, right? So if we were trying to figure this one out, we're going to start with the 0 first, right? And then 0 and 1. So that is going to be false positive. So that's going to be this very first one. So 0 being the first there, that's false. And then the second would be the predicted. Because you always start with actual. You start with actual. Predicted is going to be second. So that's going to be false positive. That only leaves one left, but that is, remember, it's always going to start when you have a 1 and a 0 together. It's always going to start with the word false, but you're ending with a 0. So it's going to be false negative. And that's how we're going to work out this first one. All right. So when we get to example 2, things are mixed up a little bit. We still have actual versus predicted. Okay. But notice that we're not using 1s and 0s on this example. They're using the word false and true, false and true. Okay, so this is different. Instead of this being, this would actually be 0, 0 and 1, 1. But instead of using those, they're using the words, and this is scrambled up a little bit. When you are working with some AI, it will not say 1s and 0s on here, and it may be in different positions than what you see here. What I've got in this example here is sort of like a traditional way of doing it, but in some AI, you may see it something along these lines. Okay, so just be aware of that. So the good news is I'm showing you how you can figure things out. So we're going to start with our first two. And we know that 2 trues, it's going to be true positive, right? So 2 trues, that's going to be this block right here. So that's going to be, in this case, that's going to be my true positive. All right? And then we want to find our 2 falses together. So this false and this false, that's like having 2 zeros together. That's our true negative. So we're going to put our true negative right here. Okay? And then we're going to remember everything else is going to be false. So really all we got to do is focus on the second word here. If it's a true, it's going to say positive. If it's a false, it's going to say negative. Okay. So let's start with this box here. All right. So we know that when you don't have 2 trues together or 2 falses together, it's not going to be a true in the first word. The second word will always be the predicted, so that's false. So that's going to be our false negative right here. False negative. And then, of course, in this case, the second word, which is going to be the predicted word, is going to be true. That's going to be a positive, so that's going to be false positive. So this takes a little practice. It takes a little figuring. But if you work at it, and if you still don't get it, watch this video again. But it just takes a little practice and takes a little thought to kind of put that all together. But if you practice that a little bit, study it a little bit, you'll have no problem understanding how to label a confusion matrix like I've done here. Okay. Hopefully you have a better understanding of it. Again, feel free to watch this video again if that's a little bit confusing. Sometimes you got to hear it again so it'll stick. But I think you'll get it if you think about it. And remember, the best way to do it is work these out first. If you're dealing with a binary version of it, that's going to be your 2 1s together. That's going to be your true positive. If you're dealing with zeros, that's going to be your 2 negatives together. So that's going to be your true negative. And then remember, everything else is false, and really all you got to do at that point is focus on the predicted results, because that's going to be the second word, right? So we know this is going to be false positive. Second word has a true, and then we know that this one here is going to be negative. Second word, so that's false negative. Same thing over here, except we're using words instead of 1s and 0s to figure it out. All right. So again, study up on that. I think you'll be fine on that. Pretty straightforward. Might want to watch the video again if it doesn't stick, but I think you'll get it if you just practice it a little bit. I now want to talk about the concept of clustering in machine learning. Now, the idea of clustering with machine learning is utilizing what's known as an unsupervised engine. And the idea of an unsupervised engine with machine learning is where we can train a model to basically separate objects into different clusters, also known as partitions, based purely on their characteristics. All right. There doesn't have to be any previously known cluster values or labels or any of that in order for this to operate. Now, one thing right out of the gates that some people get confused on with this is what's the difference between clustering versus classification. Well, with classification, this is going to sort data into specific categories using a labeling data set. You have to go through and select the label and all that you want. With clustering into partitions, it's actually individually separating objects into what's called a partition or separate groups called a cluster that's going to separate these objects out. If you were doing this with images, you would separate it into different images. If you're doing it with like a CSV file, you're talking about doing breaking data up into separate CSV comma separated value data. In my little example here, I have a real simplistic idea. I've got all of these images showing baseballs, soccer balls, and basketballs. By running this input data set into a Azure Machine Learning engine, also known as K-means clustering, that's going to be the component you would use, you would get an output where it would actually separate these into separate clusters, the basketballs, the baseballs, and the soccer balls. Okay, an example of this in Azure of the pipeline might look something along these lines here, where you got your information going in, your column data set. You could normalize the data if you wanted to have certain things removed. You've got your train cluster model, and that's where you've got your k-means clustering component hooked up here. You're taking the output, converting that into CSV, and then if you wanted to select specific columns from that data, you would do that here. So this is just an example of a pipeline you could use. All right. Hopefully that now helps you understand the concept of using a clustering machine learning engine. Hey, this is John Christopher. I hope you enjoyed getting to experience a little bit of this course, and I hope you'll join me on the full adventure. If you'll check the description of this video, you'll see a link that'll show you how you can get access to the full course. Now, in the full course, you're going to learn how to set up a practice environment where you can practice hands-on, and I'm going to provide you with lots of virtual simulations that you can do 24/7. All you need is a web browser. So I hope you'll join me, and I hope you'll also give me a like and subscribe. I'm trying very, very hard to get this channel to build and grow, and so I hope you'll take the time to do that.